Nie chcesz przeoczyć żadnego wideo? Subskrybuj kanał i kliknij dzwoneczek.
Hello everybody, my name is Hemmo Määttänen and I work for MagiCAD, the MEP software solutions, and I'm here today to talk with a few words on what kind of concrete things we are working with when we acquire BIM, all the way from the entire building perspective to a product level, and how these concrete things can benefit us when we have BIM workflows in place in general. Yes, I have worked for MagiCAD 6 years now, doing customer support, these conferences, testing, and I'm located here in Finland. Just a few words on us. So MagiCAD is an add-in tool on top of Revit and AutoCAD. We have soon 40 years of experience in offering MEP modeling solutions, like 3D modeling calculations. But one of the biggest strengths, I think, is having a wide product library with real manufactured products that contribute with like accurate technical data that our customers can rely on when they do modeling with our tools. And also manufacturers often have their own plugin tools that we offer through our software. And yeah, because of the Finnish origin, we have a strong foothold in the Nordics. And but here we have some worldwide key figures on how many countries, plus 190 countries at the moment, with a big variety of BIM objects available and cloud library users. And yes, feel free to ask any questions in the chat. I will reply on them, and then afterwards by email. So BIM in design, a construction management Association of America finds out in their annual surveys that one of the biggest experienced challenges is missing information in the design phase. Like you can see, the 92% of the respondents think this is a big challenge, and extra wishes from the clients or other alteration needs do often appear like drops along the way, and often at a late phase, which cause a lot of expenses, of course, and leads to the fact that designs needs to be made like not having all the information available there. So here we can see in the circle that BIM, this BIM process is like a circle, starting with the design and ending with the facilities management, or if we are accurate, not there, but like it continues over to the demolition phase as well. But anyway, BIM brings these project participants together, hopefully in a closed circle, so that all the information doesn't escape the circle, and in the form of technology that allows smooth collaboration, and also like develop design tools that in turn ensure a transparent result. And in that way, like we can tackle these experienced challenges, hopefully with the information but also other challenges like carbon emissions or just change orders. And therefore, when we go on in a circle, the construction phase in this way unavoidably like reflects those inaccuracies of the design phase. Like we can see here that the waste and schedules have been experienced as big challenges in the construction phase. And therefore, the design and the used technology there plays a major role. How to avoid challenges in latter phases of the process. And if we they're like then quantity takeoffs and prefabricated products are essential in this regard. But essentially, it's like the time and schedule related information. So if we take a closer look on the construction process from different stakeholders' perspective, we can see here that decisions tend to take place on a latter phase when it comes to like some supplier decisions or products. So hopefully, like basically in engineering and construction phase, but then hopefully if we acquire BIM, we can push these decisions to happen in an early phase of the circle. And not only earlier, but maybe the decisions can be made like simultaneously by all the project contributors. And maybe technical planners having more information to do their modeling and calculations on in an earlier phase. Well, this means that the end customers do not necessarily have like more influence, but they will at least like have a better understanding about the whole entire process, and maybe therefore like more involvement and engagement, and decisions may be like more data driven in that sense. And we can also take a even more or even wider perspective look on the carbon emissions. So if we divide like the carbon emissions on this embodied and operating carbon, like embodied being if we look at the whole life cycle from construction and demolition, and operation carbon being like the actual usage and maintaining of the building. So it is estimated that the operational carbon now accounts for roughly 80%, a major part of the total carbon emission throughout the whole building life cycle. But that difference will level out in the future when the operational efficiency improves. And here's where BIM and life cycle assessment come in picture, because this is exactly where what we can affect in design phase. And the life cycle assessment thinking can be like boiled down from the whole entire lifespan level to the component level, like for like a single valve, for instance. But so what are the actual concrete tools and measures that we can take to achieve this BIM process and a sustainable process? So we can begin with the energy simulations here. like better predictability. With the simulations, we have better predictability in terms of costs and of course emissions, and maybe it also contributes to a longer life cycle for the entire building because the performance is optimized. And this simulation kind of creates a positive chain reaction, like beginning with this accurate simulation, optimized choice of devices like air handling units, terminals, and of course what's the main target here is of course the improved indoor climate quality for the occupants there, and like I said, better predictability in general. So having this foundation in place in form of simulations, we can start looking at the component level, like air handling units. So as the simulations as starting point, we can optimize the selection of air handling units, for instance, and furthermore finding like the correct duct dimensions for a reasonable air velocity, and therefore decrease generated pressure losses and noise. We can find through calculation, we will find the volume control dampers and presetting values of them. So optimized solutions lead to decreasing energy consumption and pressure loss. And this is like an example what many of our manufacturer customers offer through their own plugins. Not only the library, a big variety of products there in libraries, but the selection tools that help us like filter out the correct product from that library. And electrical side is no different, because when we have a detailed and systems in place with the correct products, it helps us in doing the electrical calculations, beginning from like exact cable lengths and dimensioning, and all the voltage drops and short circuit calculations that follow. And that information in turn is then pushed back from the calculation to the model, so the information will remain there in the model and be available. So these calculations and the product selections and libraries are an example on concrete tools that we can utilize, and they're physical objects. But then the communication part is equally essential and an essential part of BIM as well. And a good example and proof of that is the provision creation loop or process. So this kind of brings the MEP engineers and structural engineers together and forces them to cooperate. Because there can be, of course, like thousands of provisions, and with the tools and prefabrication, we can minimize the need to be on site monitoring the processes and maybe doing like on-site solutions for issues. So beginning with the 3D modeling of the systems, we will be able to create the provisions around them, synchronize those provisions with the actual structural models, and finally model the actual openings. So everything will be ready in good time. And if there are, like there always is, of course, issues, feedback that provisions cannot be created in some specific place, the loop or the process can begin again with the correct tool and communication. So, but in early phase, so nothing is even before the actual problem exists, we can through the model try to solve issues. But of course, in real life, it's not that easy, of course. But therefore, also when it comes to clashes, we want to actually also avoid cooperation. And these clashes between different systems is again a good example on that. Because of course the nowadays the density of MEP objects in a building project can be huge. So the earlier we can avoid clashes and solve the problems before they even exist, the better. And therefore we need real-time clash detection and easy communication with the stakeholders. Because the more we need to cooperate in terms of clashes, for instance, the more delays there will be. And but yeah, the better the tools, the better the greater the chance that some BIM coordinator doesn't have to solve these issues then in a later phase of the project. So when we if we take a look back on the life cycle assessment, like I said, we can bring that down to a component level, taking a look at single components and their life cycle, and not only the technical performance of them, but like maintenance and installation and such. And also like the different markets have different requirements as well, like for symbols. So therefore, the different market requirements will be met as well. In form of symbols, let's say, or different calculation standards. So what would be the way to like investigate at what our what your situation is at the moment? So and what's the transformation on the way to being better BIM? So of course the first step would be like identifying the current situation, and I don't think this acquiring BIM is not necessarily any different from acquiring any new working method, because the steps are the same. And like in this case, identifying the technologies that can add value to you, like BIM objects, for instance, and targets being the second step where you want to be. But of course, this doesn't necessarily, this is not up to you completely because of like some legal requirements and the BIM maturity level of your partners. Because there might be like project specific requirements like there nowadays are many, like on a national level even. But like finding the motivation and developing a value proposition and business cases can create motivation to you to do the change, and that will probably speed up the process, so that you can in the last phase promote like good organizational culture and lifelong learning, so that the building modeling that we have in place maybe today will be the one with the I in the middle, BIM, building information modeling. One example on a very sustainable and BIM approach we have here from Oslo, Norway, a commercial building project where very much of the focus was put in sustainability and green values. This is a building with offices, restaurants, and wellness facilities, a very versatile purpose. And this building that was finalized a year back is also a BREEAM certified building. BREEAM being like this tool for rating, international tool for rating buildings in terms of energy, water, materials, waste and pollution, but it also covers like management and transportation and well-being of the occupants in the building. So where MagiCAD comes into picture with this building is that the design in this project there were like MagiCAD for Revit ventilation, piping, and schematics used, and through the accurate HVAC calculation and product selection, they were able to like optimize the systems and the system performance down to component level. And here they also used the Zobacz manufacturer plugin to select the correct air handling units for this building. As a summary, we can say that if we take a look back in the beginning, we can avoid wasting time and money, to put it simply, in many aspects. Like you can see there, materials, carbon, and the reaction to the change requirements. Of course, we cannot avoid like changes that would be maybe impossible, but at least we have the right tools to meet those requirements. And decisions that can be made early enough and data-driven design and decision making due to accurate technical data of manufacturer provided products, and yeah, not only the performance but the whole life cycle. And the design cost, like we can see here, it's only the tip of the iceberg, but decisions made in the design phase affect the whole process. And BIM is of course in its core, it's like risk management, because it's a building is a huge cost, so it's in everybody's interest to plan it well. And higher level of BIM means more benefits to harvest. Yes, I thank you on my behalf. Like I said, feel free to send me email, ask questions. Let's keep in touch. Thank you on my behalf. It was a pleasure to be here.
Nie chcesz przeoczyć żadnego wideo? Subskrybuj kanał i kliknij dzwoneczek.